Welcome to Deep Dive, where we get past paper question and we dive deep into them. So this is the 8th episode of Deep Dive and the last part of 2020 MCQ paper. I'm your host Shan Singh and let's start. 37th question. A 4 Newton force and a 3 Newton force are applied on an object at the same instance. Consider the following statements given about the magnitude of the resultant obtainable at that occasion. So, two forces are applied to an object. Let's represent the object with O and forces used in arrows. So, there are three possible scenarios when two forces and one object is present. One, the both forces are applied to the same direction, as you can see here, or both into the right side or the left side, which will result in a 4 plus 3 magnitude, which is 7 newtons. Then the second option, the forces are applied in the opposite direction, as you can see here, which will result in 4 minus 3 magnitude, which is 1 newton. The third one, the forces are applied in different angles other than 180, which will result in a magnitude anywhere between 1 Newton and 7 Newton. So let's get to the question. The three statements. A, the maximum magnitude of the resultant obtainable is 7 Newton, which is correct. Then B, the minimum magnitude of the resultant obtainable is 1 Newton, which is also correct. C, the magnitude of the resultant obtainable is always 5 Newton, which is incorrect. So the correct answer is going to be 4. Then 38th question. A strong bar magnet is moved into and away from an insulated wire coil with a large number of turns as illustrated by the diagram. What is the correct observation about the instances of movement of the magnet? So you can see the circuit here. We have south and north, a magnet, and then we have a bulb, and it is parallelly connected to two diodes, LEDs, light emitting diodes. Even though this looks like a question about electromagnetic induction, it is about the nature of a current flow when diodes are present. What we have to remember here is that LEDs are diodes, and that you can see the arrow in the LED, right? That where the arrowhead is pointed towards is the direction of the current flow that the LED would allow. When the magnet is pushed into the coil, the current starts to flow in one direction. When it's pulled out, the current flows in the other direction and it is blocked by the other LED. So in both instances, one LED would be lit. But the way the circuit is positioned, no matter which diode is active, the bulb would be lit, because when one circuit closed by one LED, the other is open. Look at the diagram, the circuit. So imagine the current is coming from the left side and down, and comes down, and it divides into three wires. And because of the LED in the bottom is blocking the bottom path, the current is going to go through the LED in the top LED and the bulb and connect to the other side. And when the current is coming from the right side, it divides into three. The middle path gets blocked by the LED in the top, and the bottom part is allowed by the LED. So the current goes from there and from the light, from the bulb, and it goes to the left side and connects to the circuit. So it always one of the LEDs lighting up, and the bulb is always lit. So the correct option is going to be second option. In both instances, the bulb lights and only one LED lights. 39th question. Consider the following statement. A. Biomagnification occurs along a food chain. B. Toxic chemical pollutants concentrate more in the upper trophic levels of food chain, which is correct. So, as organisms at lower trophic levels are consumed by organisms at higher trophic levels, the concentration of pollutants can increase through a process called biomagnification. This occurs because the pollutants that were stored in the tissues of prey organisms are transferred into the tissues of their predators. As a result, organisms at higher trophic levels, such as top predators, can accumulate high concentrations of pollutants in their body, like higher amounts of mercury in larger fish that are in the top of the food chain. In biomagnification, for an example, you can look at the picture. So when factories and like ships and even normal waste gets into the ocean or body of water, uh, they can these heavy metals like mercury. The thing about heavy metals is that when they get into your body, they don't get out. It stays in the body. That's the issue with heavy metals. The time as time goes on, as you get older, you can get more and more, but they don't go away. They stays in your body, in your tissues. This is known as bioaccumulation. But when it comes to biomagnification, what happens is these mixed heavy metals get absorbed by phytoplanktons, which are like microorganisms that can, through photosynthesis, uh, and then they get eaten by zooplanktons. When imagine the phytoplanktons, they get one mercury atom in their body by just eating something. The zooplankton eats like maybe 5 of them per meal, and maybe they eat 3 times a day, like 15 a day. So that's like 15 atoms of mercury. And imagine they eat for 10 days, that 150 atoms of mercury in one zooplankton. And then a very small fish eats like maybe 10 of them per meal. That's what? 1500 atoms of mercury. That's just for a meal. Maybe that little fish eats like for 10 days. One meal per day. Let's think that they eat one meal per day. So in 10 days, the small fish eats these with mercury zooplanktons. That is like 15,000, right? 15,000 in atoms of mercury in one small fish. And then a salmon eats that small fish, maybe like salmon eats like 100 of them in like a week. How much is that? 1,500,000 atoms of mercury in one salmon. Now in the picture, an orca eats it. Imagine we eat it. We humans, we get that exact same amount of mercury. 100, like what, 150,000? I think I lost the math on the way here. So you get it, right? How much they get eaten, the amount of mercury gets magnified along the food chain, mercury, whatever pollutant. So that is biomagnification. It's a very serious issue. That's why it's not really safe to eat a lot of large animals, top predators like whales, dolphins. By the way, orca is a dolphin. Killer whale, orca. They are technically a dolphin. Fun fact for you. Okay, the last question of the paper. A statement displayed on a board near a tank is shown in the figure. Which of the following human activities in connection with the tank would have contributed most to the change mentioned on the board? The board says, "It is you who turned the water in this tank green." Very aggressive. I just got here. I don't know. So, the reason this tank has turned green is due to the growth of algae. Algae are microscopic organisms that are naturally present in water bodies, and they can multiply rapidly under certain conditions, leading to an overgrowth known as an algal bloom. When algae multiply rapidly, they can form dense colonies, give the water a greenish hue. This not only affects the aesthetic appearance of the water, but can also lead to issues such as clogging of filters, depletion of oxygen levels, the production of toxins harmful to the aquatic life and human. Let's go to the options. One, clearing the area above the tank. That's no. Two, increase in algae population due to fishing. Fishing does not increase the algae population. Three, accumulation of oil and grease due to vehicle wash. So the thing it means these oils and grease with vehicle wash is that harmful chemicals get in that does not lead to a optimal condition for algae to growth. It's toxins, right? For algae as well. It's toxic. Fourth, additional of fecal and excretory matter to the water. So fecal matter means poop, caca, shit. So this is a very good growth medium to the algae. So the answer is going to be 4. So here we finish our first past paper discussion, the deep dive series, first one. Thank you very much for staying with me all these 8 episodes, and I hope you learned something new, understood something you couldn't understand before. Don't forget to share this with your friends. And if you are pursuing science after O levels, I'd ask for a subscribe, because I'm not just going to upload past paper discussions, but I would also upload other concepts is being discussed, different science things, the new papers they publish. I would talk about them, and different fun videos, experiments, and such. So this is just the beginning. If you are watching these before O levels, good luck on your O-level examinations. You can email me and get the paper and read through it again if you don't have time to watch the videos again. And yet again, good luck and thank you for tuning in. Bye.